Shall we begin? Yesterday we talked about simple mechanism, and I hope that simple mechanism wala concept is clear to everyone. What is simple mechanism? How many links are there? What kind of pairs we are going to have? Lower pair or higher pair? What is lower pair? What is higher pair? Everything we have seen. What questions are going to be asked? They will be asking questions on degree of freedom. है ना? So 1 degree of freedom wala mechanism is in our syllabus. There are situations where you can also have degree of freedom 2, degree of freedom 3. Higher degrees of freedom wala mechanisms also exist, but we will focus only on 1 degree of freedom wala mechanism. Only one input is required. Any one link ko you are going to give motion. Other links will have a constrained motion. All other links ka motion will depend only on this one link's motion. Just give motion to this link. Just connect motor here. Its motion is going to decide all other links ka motion. That's the beauty of having degree of freedom 1. So today in this lecture number 2, we will be talking about velocity analysis. What is the meaning of velocity analysis? What we are going to do in this chapter, and how they are going to ask questions. Listen very, very carefully. Till this point, everybody has agreed with me that we are talking about degree of freedom 1 mechanism, and if degree of freedom is 1, that means only one link ka motion I will decide, only one input is required. So motion of one link is given at any instant, and they can ask all other links ka velocity, and we can calculate that. Why? Because only one link ka motion, whatever you have decided, all other link ka motion is going to depend on this. ठीक है, degree of freedom 1. If it is degree of freedom 2 वाला mechanism, तो फिर any 2 links का motion you have to provide me, then I will be able to calculate all other links का velocities. So motion of any one link is given, other links velocity we can find. Other links velocity we can calculate. If you are agreeing with me at this point, then we can start our questions. There are basically 2 approaches beta. To solve motion, we are having 2 beautiful approaches. Velocity analysis के लिए, analysis का मतलब समझ रहे हैं? What is the meaning of analysis? Analysis means finding out the velocities. So we are having 2 beautiful approach. First is, which we are calling it as eye-center method, and then we have which is called as another method which is called as relative velocity method. This is also known as graphical method. Relative velocity method, or also called as graphical method. Be very, very careful. First, we'll be talking about eye-center method, and believe me, majority of the questions which are asked in GATE, 90% question, 95% questions can be solved with the help of eye-center method. There will be questions, all questions you can solve either by this method or by this method, but most of the time we are going to use this method. ठीक है? First of all, what is this eye-center? होता क्या है? What is the meaning of eye-center? Listen carefully. What is the meaning of eye-center of any relative motion? Careful. Suppose if I am saying that I have some link may look like this. At an instant, this link was looking like this, and with respect to any other link, I was sitting at that link and I am seeing the motion of this particular link. That other link, what is that link? Sir, it can be anything. like in a mechanism we are having 4 links, 5 links, है ना. So suppose link number 1, which is generally fixed link number 2, link number 3, link number 4, 5. I'm talking about motion of link number 4. This link is doing some motion. I want to see its motion. From where I can see? You can see its motion with respect to any other link. Sir, from link 1, can I see this motion? Yes. Sitting on link 2, can I see this motion? Yes. Sitting on link 3, can I see this motion? Yes. So, whatever motions you are seeing, that is called as relative motion of this link number 4 as seen from link number 1, or as seen from link number 2, or as seen from link number 3. So, any link ka motion you can see from any other link. Relative motion. Motion is always a relative term. So, suppose this link is doing some motion with respect to fixed link. Fixed link, this board, this is my link number 1 and this is my link number 2. Link 1 ke respect mein, link 2 is doing some motion. And this motion is a general motion. Most of the time you will find that links, neither they are going to have pure rotation nor they are going to have pure translation. Actually links, most of the links, they have general motion. What is the meaning of general motion? General motion means combination of both. We will be having link which is having translation as well as rotation. Simultaneous. What is the meaning of this? Arey bhai, if this link was having only pure rotation about this end, है ना? Suppose this was doing with respect to this fixed link was doing some pure rotation. What is the meaning of this pure rotation? That at any instant link's ka position was this. So because it is having pure rotation, so just next moment this link will move somewhere here. Can you see? Sir, link ka only orientation has changed. Position of the link has not changed. Link was here, link is here. It was here, it is at this position only. Only its orientation is changed. It was vertical, now it is at some 60-degree angle. Next moment it will be at some 30-degree angle, and so on. Only its orientation is going to change. And how do we solve these rotation wala thing, rotation wala motion? I know this. You just tell me what is the omega. So I can very easily tell every point ka velocity from here, rotating body ka. This is the beauty, that if you are sitting at the center of rotation, look at the any point. If you are talking about this particular point, velocity will be perpendicular direction mein somewhere here. If you are talking about any other point here, so whatever is this radius r multiplied by omega, you will get perpendicular direction again velocity like this. So this is the beauty of any body which is having rotation. So from the center of rotation, velocity of any point will be perpendicular. Perpendicular to what? From the center, connect this point. So this line of sight ka perpendicular direction mein we are going to have velocity. That's the beauty of rotation. How do we solve rotation? I know this. If suppose this is the pure rotation wala case, if it is pure rotation, I can solve this very easily. Now imagine kariye, if any link is doing pure translation, what is the meaning of this? Pure translation. If any link is doing pure translation, it means that this particular link, if it is having pure translation, so any point, sir, this point, this point, this point, this point, every point will have same velocity. It means that if you are talking about this point, suppose it is moving here, so every point will be moving in the same direction with the same magnitude. That means every point will have same velocity. What does it mean? At this instant you are seeing that this link is at this location at making some angle 60 degree. Very next moment it will be somewhere here. It will change its position. Means this point will move here, this point will move here, this point will move here, this point will move here. Every point is having same velocity. Same velocity means same magnitude and same direction. So only link ka position has changed, orientation is not changed. And if anybody is having translatory motion, so how do we solve translatory motion? I know this. Tell me one link where one point is having this particular motion in some direction, so every other point ka velocity I know it. This link, very in some 2 seconds, where it will be, where this link will be positioned after 2 seconds, I can also calculate this. So I know everything how to solve pure translatory wala motion. I know how to solve pure rotation wala motion. And if I show the velocities of the pure rotating link, its velocity will look something like, sir, this is the center of rotation, and if you are talking about this particular point, so line from the center, line of sight ka perpendicular direction mein I am going to have velocity. Sir, ye hai velocity. Sir, if I am talking about this point, what will be velocity? Sir, from the center, velocity again it is in the perpendicular direction. But obvious बात है, magnitude is a little smaller. Common sense वाली बात. If you are talking about this point, it will be again from the center, line of sight ka, this is the line of sight, its perpendicular direction mein we are going to have velocity, perpendicular direction mein we are having velocity, but magnitude is going to change. So I hope everybody is comfortable with this concept ki haan sir, if something is having pure rotation, velocities are like this. If something is having pure translation, velocities are like this. Same velocities. Here we are having different velocities. How to solve rotation, how to solve pure translation, I know. But what if I say that most of the times you will be dealing with the links which are neither having pure translation nor pure rotation. They are having general motion, as I have mentioned earlier. If something is having general motion, so it will be actually having translation plus rotation. Now imagine kariye, if rotation and translation both are happening simultaneously, that means this particular link, after some time, it will not only change its position will change because translation is there, and while it has changed its position, its orientation will also change. So this link will be from this position to this new position. What is this new position? Sir, position has changed as well as its orientation has also changed. And this thing is happening simultaneously. So this link has moved something like this. What I'm saying, that this link is doing general motion. How to solve general motion? We have no clear idea about this. One student suggested, sir, if you don't know how to solve general motion, why don't you do one thing? Take any 2 point on this. Any 2 point. Is it necessary to take n points? No. Whatever 2 points you can comfortably see, take any 2 points. And suppose these 2 points were having some random direction where they are having some velocities. So this point was having this velocity and this point was having this velocity. Some random velocities. Let me call this is point A, this is your point B. So this is velocity of point A, velocity of point B. A student said, sir, do one thing. Draw perpendicular of this velocity. Okay. Draw another perpendicular of this velocity. Okay. And whenever these two perpendiculars are intersecting, that particular point I am going to call it as, this is my eye center. This is my eye center. What is the beauty of this eye center? Sir, from the eye center, if I sit down here and start looking at this link, how does it feel? Sir, from this center, if I am looking at this point A, its velocity is perpendicular to the line of sight. And from the same center, if I am looking at this point B, its velocity is again perpendicular direction mein. So whenever I am sitting at some location and link ka any point I am seeing and this velocity is perpendicular direction mein, that means from this particular point I am getting feeling that this link about this point is doing pure rotation. And once you know that pure rotation I can see here, what velocity, what omega, I don't know, but some omega is there. Getting my point? Now what you have to do? Sir, once you know where is the omega, where is this eye center, This is called as I center, instantaneous center of rotation. At this instant, from the center, I can feel the rotation. I can feel the rotation, and that's why it is also called as virtual center of rotation. You may call it as virtual center of rotation or instantaneous center of rotation. Very, very careful. This is instantaneous center of rotation. Very next moment, sir, this is what you have done. You just have taken velocities ka direction and drawn the perpendiculars. They are intersecting at some location. I center, you are saying. Very next moment, this link from here, it will move to some new place. Velocities will be some other random direction way. So again, you will draw the perpendiculars. That perpendiculars may intersect at some different location. That means now from that location you are feeling the rotation. Getting my point? So instead of saying this point as center of rotation, it is better to say instantaneous center of rotation. At this instant, from this location, I am seeing the rotation of this particular link. Getting my point? Second point. Suppose location of I center you have already got. If you know any of these velocities, suppose velocity of point A is known to you. Any of these velocity, either this or this, magnitude is known to you. So if you know what is the velocity, so you can very easily find out the omega. How? Sir, from this I center, just find out, just measure how much is this distance. Can I write? I center say this point A ka distance multiplied by omega. R omega is nothing but velocity. Can I write? Velocity of point A will be equal to, from the I center to the point A ka distance, IA times omega. So what is the omega? Sir, omega is velocity of A divided by IA. And from here you have got what is the value of omega. For this link, what is the value of omega? And once you know that this link is rotating with what angular velocity omega, so every point ka velocity, somebody is asking velocity of point B, I can write I center say just measure this distance IB multiplied by omega. That's it. Sir, just put this omega which you have calculated here. If somebody is asking, tell me midpoint of this link, this is point C. What is the velocity of point C? Nothing we have to do. Sir, from this I center, just measure the distance. Whatever is the distance, measure it. And perpendicular direction mein, I'll be having some velocity. This is the velocity of point C. How do I write this? Sir, velocity of point C is nothing but I center say point C ka distance multiplied by omega. That's it. As simple as that. How many of you are comfortable? Tell me in the chat box. Simple sa concept. Concept wala part was only this. है ना? So how do we find the I center? And once we have find out the I center, what next we have to do? We have to do analysis like this. Simple सी बात. अच्छा जी. Suppose we are having any mechanism. So any mechanism which is having n number of links, है ना? Mechanism having n links. Number of links, how many? N number of links. So whatever number of pairs you can see, those many number of I centers we are going to have. Number of pairs का मतलब है भाई I center is defined for a pair. Pair का मतलब for relative motion. Any one link का relative motion I can see from anywhere. I'm not talking about that physical connection wala pair. That link 1 is connected to link 2. This is the pair. I'm not talking about this joint. I'm not talking about joint. I am talking about any two bodies ka combination. Suppose I have so many links. Link 1, link 2, link 3, link 4. Link 1, link 2, link 3, link 4. तो लिंक 3 का मोशन फ्रॉम हेयर यू कैन सी, सर लिंक 3 का मोशन यू कैन सी with respect to link 1. With respect to link 1, what is the velocity of link 3? I can by link 3, link 1, these are the two links. Between these two links there will be some relative motion. So link 1 के रिस्पेक्ट में link 3 का मोशन I can see. Link 2 के रिस्पेक्ट में link 3 का मोशन I can see. Link 4 के रिस्पेक्ट में link 3 का मोशन I can see. Getting my point? It is not necessary that two links must be directly connected. They must form a joint. No, it is not necessary. Getting my point? So if I am having n number of links, so number of eye centers are how many? Sir, you are going to have number of eye centers will be number of pairs. How many pairs we can find? N links, say two links ka pair. How many links we can find? We can have nc2, and that I can write n minus 1 divided by 2. This is the number of eye centers. How many number of eye centers are there? These many number of eye centers. Examinations में some small level examinations like IES pre, they can ask questions. They have asked questions multiple times. They will give, we have 6 links. Tell me how many eye centers are there. Suppose we are having 6 links. How many eye centers will be there, sir? 6 minus 1 divided by 2. कितना हो जाएगा? How much? 30 divided by 2. This is 15. Total 15 eye centers. If we are having 4 links, how many eye centers will be there, beta? Sir, 4 minus 1 divided by 2. 4 3 is 12 by 2, 6. 6 eye centers. Getting a point? Now let me tell you, what are these 6 eye centers? Suppose, how do I give name to these eye centers? Careful, careful, careful. Suppose links, I have given it some name. And we are having link 1, link 2, link 3, and this is link 4. Everyone knows that in any mechanism we are having some links. Fixed link ko always I am calling it as link number 1. Always. And everybody is doing this. We also have to follow this. So this link number 1 is fixed link always. What are the eye centers? Sir, there are 4 links. How many eye centers? N ka value is 4. Number of links are 4. So number of eye centers will be, number of eye centers will be 4 minus 1 divided by 2. There will be 6 eye centers. What are these 6 eye centers? Pairs. Write down the pairs. Sir, link, how I am writing? Careful. Link 1 ka pair with 2, link 1 ka pair with 3, and link 1 ka pair with 4. So I12, 13 and 14 I am going to have. 12, 13 and 14 I am going to have. ठीक है? Link 1 का pair 2, 3 and 4 के साथ I have seen. Now let's talk about link 2. Sir, link 2 का pair, don't say with link 1, because already 1 and 2 pair I have already seen. So 1 and 2 का pair or 2 and 1 they are following pair, this is nothing but same. We are talking about combination, not permutation. Link 1 and link 2, for this pair, whatever relative motion is there, I can see this relative motion from some eye center as pure rotation. I have already found out that eye center, it is I12. So link 2, it is making pair with, don't call link 1 again. Why? Already 1, 2 I have written. So go ahead, link 2 ke saath 3 and 4. So you will be having link 2, 3 this pair and link 2, 4 this pair. Now talk about link 3. Don't look back. 3 is having pair with 4. These are the total 6 eye centers which I am looking for. 6 eye centers, 1, 2, 3, 4, 5, 6. These are the 6 eye centers which I am looking for. बात समझ में आ गई? What are these 6 eye centers? Out of all these eye centers, I12, I13, I14, 23, 24, 3 है ना 3 4 these are the eye centers. So link 4 का motion, like link 4 का motion you can see from I14 also, link 4 का motion you can see from I24 also, and link 4 का motion you can also see from I34. Link 4 का motion can be seen from any of these 3 eye centers, but whenever I am seeing link 4 का motion from I14, this is the eye center which is associated with link 1 and link 4. From this eye center, what you are going to see, sir? I14 say what you will see. Let me write. I14 say you will see angular speed of link 4 with respect to 1. Angular speed of link 4 with respect to link 1. And how many of you know this? That link 1 is actually a fixed link. So whenever I see relative motion of any body with respect to fixed body, so that relative motion becomes absolute motion, है ना? It means link 4 का motion whichever I have seen from here, I can also see from I34, I24, but from I14 I will be seeing link 4 का absolute motion. And same logic say I13, I12, all these eye centers are going to give me absolute rotations of link 4, of link 3 and link 2. बात समझ में आ रही है? So these eye centers are something unique, something special. As an example, suppose if I'm having 5 links, 6 links, sir, number of link is 6. How many eye centers will be there? Sir, we are going to have 6 minus 1 divided by 2. 6 5 are 30 divided by 2, this is 15. 15 eye centers will be having. Let me give it the let me write down the name of eye centers. First, what are the links? Sir, I'm having link 1, link 2, link 3, link 4, link 5, link 6. These 6 eye centers we are having. 6 eye centers we are having. What is the name of eye centers? With 1, you will be having I12, 13, 14, 15, 16. These eye centers. With 2, 23, 24, 25, 26. With 3, 34, 35, 36. 34, 35, 36. What about 4? 4, 5, 4, 6. 4, 5, 4, 6. What about 5? 5, 6. So how I am writing this? I hope everybody is getting it. These are the total 15 eye centers which we have to look for. And out of all these eye centers, sir, link 6 ka motion from here we can see from 5, 6, 4, 6, 3, 6, 2, 6, 1, 6. I can see link 6 ka motion from all these locations. But I16 is something from where link 6 ka absolute rotation is seen. And similarly, I12, 13, 14, 15, 16, these eye centers will be giving me link 2 ka, link 3 ka, link 4 ka, 5 ka, 6 ka absolute rotation. Getting my point? This much concept I hope everybody is clear with. Now, the major question is, sir, how to find out in real problem, how to find out location of eye center? कैसे निकालेंगे? There will be some basic eye centers which you can directly tell, है ना? Basic common sense वाले eye centers, basic eye centers. Say for example, if we are having a turning pair, what is the meaning of turning pair? Sir, any two link which they are connected by pin joint. Suppose we are having these two bodies, है ना? And links, this is link number 2, this is link number 3. These are the two links, ठीक है? And they are connected with the help of pin joint here. They are having some general motion. General motion का मतलब they are also having translation together, and while they are having translation, between the pair there is some motion, है ना? Between the pair there is some motion, and that pair is also having some translatory motion. Or while they were having this translation, they were also having rotation between the pair, if you want to see the motion. So that's what we call as relative motion. So to see the relative motion, you have to fix in any one link. Then only you will be able to see relative motion of link 3 with respect to 2. Or if you fix this link 3, then you will be able to see link 2 ka motion with respect to 3. Just fix any one link, then only relative motion will be visible to you. With respect to 2, link 3 ka motion, I want to see as rotation. So there is no other point. You have to sit here. That pin ka center itself becomes your eye center. So this is your I23. This is the eye center I23, from where between these two links you can see pure rotation. Common sense वाली बात. अच्छा जी. Another situation. Suppose if I am having pure rolling between two bodies. Pure rolling, when it will be visible to you? Pure rolling is visible to me when on one body another body is having doing rolling motion. It can happen if we are having two cylinders having rolling motion over each other, or we may have any curved surface. On the inside the curved surface another ball is having rolling motion, or on the curved surface outside we are having any ball which is having rolling motion. So doesn't matter what is its shape, I am just focusing on the relative motion as pure rolling motion. There should not be any slip. Pure rolling, I am talking about pure rolling. Rolling pair, I am talking about rolling pair. Turning pair के बारे में बात कर लिया. We have just discussed the turning pair. Now let's talk about rolling pair. How does it look? Sir, rolling pair, suppose on one body another body is there which is doing pure rolling motion. ठीक है. Link 1, this is link 2. Together they are having some motion. They are also having translation, or they are having rotation like this, simultaneous. But if I want to see relative motion between these bodies 1 and 2, I have to fix any one body. Just fix body number 1, and then from body 1 you can see relative motion of body number 2. And this body number 2 is actually doing what? This body is rolling. Rolling ka matlab, it is translating. Its center of mass is moving ahead, and this body is also rotating. So its center of mass is moving with VCM, and this body is also rotating with some omega angular velocity. And everybody knows what is the condition of pure rolling. If this radius of the body is radius r, so pure rolling का मतलब होता है there should not be any slip. Velocity of center of mass should be equal to r omega. Omega and velocity, they are not, rotation and translation, they are not independent of each other. Omega decides with what velocity this body is going ahead. So if you are sitting at this center of mass, if this center you are sitting at, you will see translation as well as rotation. But if you sit down at this point of contact here, at this location, point of contact, this point of contact is going to become your eye center. Just sit down here, and what you will feel that about this center, this body is just rotating. Very next moment, this body has moved, this body has just moved to a new position. Point of contact will travel here. In the very next moment, point of contact will travel here. Getting my point? So where is the eye center location? Eye center is at this location. From here, this entire body with respect to one body to at this instant, it is giving you feel that about this point this entire body is getting turned. Clear hai? Third, common sense wali baat. Third situation, we are having another situation. If suppose we are having sliding pair, we may have sliding on the curved surface, है ना? sliding on the curved surface, maybe inside the curved surface concave part mein, or at the convex portion outside the curved surface. Suppose this is the body 1 and inside this body 1 we are having a slider. Slider is kept like this. Link number 1 and this is my link number 2. Inside the link number 1, body number 2 is going to have some sliding motion. Together they are having some random motion, they are also having translation, they are having rotation, but I am talking about the relative motion. When I am talking about the relative motion, that means just fix the body 1, fix this body number 1, and with respect to body 1, what this body 2 is doing, I am interested in that thing. So from here you can see link 2 ka motion as a pure rotation just by sitting at this center of the curvature of the body on which sliding is happening. Just sit down here. This is your eye center. What name I will give? I will say this is the eye center for body 1 and body 2, I12. Here, what is this eye center? What do we call this? You will say that this is your eye center, body 1 and body 2, this is the eye center. Sir, this is body 2 and 3. What is this eye center called? I23. For body 2 and 3, this is the eye center. Clear hai baat? The diagram which I have shown here, inside the curved surface body was sliding. This body may be somewhere outside also. We may have on the convex surface any body which is sliding. Then also I will have eye center of these two bodies, this body and this body. Eye center will be at the center of curvature. Clear hai baat? Sometimes we may have on some straight line, I may have any link which is having sliding motion. What is the meaning of this? Let me give it some name. This is suppose link number 1, this is link number 2. So link 1 ke respect mein this link 2 is doing sliding motion, relatively sliding motion. Together they are having some, maybe some rotation also, but with respect to 1, link 2 was sliding. With respect to 1, it means just fix this link number 1. Now if you will see the link 2, with respect to this link 1, link 2 was having only this motion. Where will be eye center? Sir, eye center find out karne ke liye there was simple some method. By any 2 points, sir, any 2 points, just find out the velocities. Sir, these are the velocities. Both the points are moving ahead. So what do we do next? Sir, just plot a perpendicular here, plot perpendicular here also, and wherever these two lines are going to intersect, that will be your eye center. I think these lines have become parallel and they will never intersect, or mathematically you can say these parallel lines are intersecting at the end, infinity, hai na? So you can simply write on any of these line, either vertically up direction mein or somewhere in the downward direction. Both ways are correct. You can simply write where is the eye center of I12. It is at the infinity. Where? Along this direction. You may write here or you may write here also. That means if you want to see this motion as pure rotation, you have to sit down at infinite, that side or this side. From infinite you will be having the rotation wala field. This concept ko I can say it in reverse manner. If between two bodies some relative motion is happening, and to see this motion as pure rotation, you have to sit at the infinity. That means between these two bodies, relative motion is actually pure translation. Getting my point? My link 2 is actually doing pure translation. So something which is having pure translation, if you want to see that motion as rotation, you have to sit down at infinite. These are the some basic eye centers which everybody must know, and I don't think that anybody is having any problem here. Second thing, sir, there will be some eye centers which I can find out using these basic logic. What about all others? Because you have shown already that for 6 links we are having 15 eye centers, and whatever eye centers basic logics I have told you, these were the eye centers of the joints. 2 links are in connection, pin joint, rolling pair wala joint, sliding pair. So where are the eye centers? I have told only those. We are having so many other eye centers. How do I find, how can I find out these eye centers? So for that there is a logic. There was a theorem given by Mr. Kennedy's theorem. Kennedy's theorem. Kennedy's theorem. What does this theorem states? This theorem says for any 3 bodies which are doing relative motion with respect to each other, for any 3 links which are doing relative motion with respect to each other, how many eye centers but we are going to have for these 3 bodies? Sir, for 3 bodies there will be 3 eye centers. Relative motion with respect to each other. Careful, careful. All 3 eye centers, all 3 eye centers associated with these 3 bodies, they must be collinear, in line, or can I say collinear? They must be collinear also. Say for example, I am talking about links, any 3 links. These 3 links may or may not be in direct connection. Link 1, 2, 3. No need to take link 1, 2, 3 in sequence. You can take link number 1, link number 2 and link number 3, or you can also take, sir, link number 2, link number 5 and link number 8. No direct connection. In any mechanism, these are the far apart links. Link 1 के साथ we have link 2, link 2 के साथ we have link 3, 3 के साथ 4, 4 के साथ 5. So there is no connection of link 2 and 5 directly. Getting my point? Any 3 links of the mechanism. What are the eye centers? Sir, 3 links के साथ how many eye centers will be there? Sir, 3 links. So 3 minus 1 divided by 2. 3 to the 6 divided by 2. 3 eye centers. So there are going to be 3 eye centers. What are the eye centers ka name? I will say I12, I13 and I23. These are the 3 eye centers. According to this theorem, I12, I23 and I13, these 3 eye centers must be in a line. They must be collinear. Similar way, say I can write here I25, I28 and I58. These must be in line. Must be in a line. This one also, these 3 and these 3 also. How will it be helpful to find out some extra eye centers? It will be very, very helpful. Why? Because suppose, sir, on any 2 points, they can be anywhere. For being in line, 1 point I have, 1 eye center I have found here. Other eye center, sir, other eye center may be somewhere here I have found. So 2 points, say passing line you will be having. Always you will be having a line which is passing through 2 points. But third point also have to be in line. That makes a very big condition. Third point cannot be here. Third point cannot be here. Third point cannot be here. Any random position where it cannot be there anywhere. It have to be on this line. This may be somewhere here, here, or here. This side, this side, this side. That means on this line only that third point have to be there. So sometimes if you want to find out some missing eye center, you can use this Kennedy's theorem. How we are going to solve the problem using this Kennedy's theorem, or how we are going to locate all the eye centers using this Kennedy's theorem, let me tell you. Suppose, very, very careful beta, suppose examiner has given me a configuration of any link, any mechanism. A mechanism is there. At any instant, it was looking like this. Something like this. Careful. Pin joint. Pin joint. This is also pin joint. This is also pin joint. These are the 4 links. है ना? Suppose this one is fixed. Let me give it name. This is fixed one. Ko always, it is my habit that I will call it as link number 1. Fixed link is always called as link number 1. Always remember this. Link 1, link 2, link 3. This is link number 4. There are 4 links. Let me make this diagram a little bit bigger. है ना? Question में they have given all links का dimension, this dimension, this dimension, every dimension they have given, and they have given that at this instant which I am talking about, link 2 was making some angle theta, 30 degree, 60 degree, whatever. So if angle is given, so rest all links, what will be their orientation I can make, because this is degree of freedom 1 wala mechanism. Degree of freedom 1 wala mechanism, it means just tell me what orientation this link is making. Other links I can draw. Everything is fixed. How do I identify the eye centers? Careful, careful, careful. Sir, some basic eye centers. First of all, what will be the eye centers? Let me write. There are 4 links. Number of links are 4. So number of eye centers will be how many? Number of eye centers will be 4. 4 minus 1 divided by 2. 6 eye centers we are going to have. What is the name of eye centers? Link 1, 2, 3, 4. We are having links. So we are going to have I12, I13, I14, 2, 3, 2, 4 and 3, 4. These are the eye centers which we are going to find. Draw a circle also. Rough circle. You have drawn a circle, and on this circle 4 links are there. So just mark 4 equidistance point. Point 1, point 2, this is point 3 and this is your point 4. These points are representing links. There are 4 links, so 4 equidistance point I have marked. This is rough work. Now identify what are the eye centers. Sir, some basic eye centers I know. Between link 1 to turning pair, so I12 will be this side. You can write this as I12 or I21, no problem. Both are same. I12. I12 I have identified location. So I12 just connect it. This is telling me for link 1 and for link 2, eye center we have find out. This is done. 2, 3, I23, sir, it will be here. So I23, just mark it that I have find out. Link 2 and 3 ke liye you have find out the eye center. So this is I34 and this is I14. So 3, 4 and 1, 4 also I have find out. 3, 4 and 1, 4 I have find out. I have to find where is the location of I13. I13 कैसे निकालेंगे भाई? Sir, I13 directly I cannot tell, because link 1 is here, link 3 is here. They are not in direct connection. They are not making a joint wala pair. But can I see link 3 ka motion with respect to link 1? Sitting at link 1, can I see this motion? Yes. And sitting at link 1, you will be seeing the link 3 ka absolute motion. So how do I find out? You can talk from the point of view of Kennedy's theorem. कैसे बात करेंगे भाई? Sir, I have to find out I13 का location. If I am talking about link 1, link 3 and link 2, these 3 links. So these 3 links के all 3 eye centers have to be in line. Link 1, link 2, link 3. I12, 2, 3 and 1, 3. They must be in line. So this triangle kind of shape which we are having, this triangle ka every side is representing eye centers which are in line. So can I write I13 will be in line with, I13 is in line with 1, 2, 2, 3, 1, 2 and 2, 3. Where is this 1, 2, 2, 3 wala line beta? 1, 2 and 2, 3 wala line, sir. 1, 2 ye hai, this is 2, 3. 1, 2 and 2, 3 wala line is this. On this line somewhere, maybe that side or this side. On this line, we are going to have our missing I center I13. Who has said this? Kennedy bhai has said this. I13 ko you can also find out if we are talking about body 1, body 4 and body 3. So all three I center associated with these three bodies, they must be in line. So 1-3 must be in line with 1-4 and 3-4. It must also be in line with 1-4, 3-4. Where is 1-4 beta? Where is 1-4? Sir, 1-4 ye hai. Where is 3-4? 3-4 is this. So just connect these two I centers, 1-4 and 3-4. On this line, we are going to have I center. So Kennedy theorem, earlier it was saying that I center must be on this line. Now Kennedy's theorem is saying it must be on this line. So there is only one point which is satisfying both these conditions, and wherever we are having intersection point, this it will be your location of I13. I13 I have calculated. Where is the I13? I have find out. Similar way, you can calculate location of 2-4. Can I write directly? I24 will be in line with 2-4 will be in line with 3-4, 2-3. 2-4 will be in line with 2-3, 3-4. It will also be in line with 1-2, 1-4. This 1-2 and 1-4. Where is 2-3, 3-4 beta? Sir, 2-3 ये है, 3-4 ये है. 3-4, 2-3. Just connect and extend this line. So on this line somewhere, maybe that side or maybe this side, I'm going to have my I center. You're also saying 1-2, 1-4 wala line. Sir, 1-4 ye hai, this is 1-2. So 1-2, 1-4 wala line, I think it is a horizontal line. Just extend this line. Somewhere that side or this side, we are going to have I center. You are saying on this line and on this line, I'll be having on to I24. So I24 ka what is the location? I24 will be somewhere here, intersection point pe. I'm going to have my I24. This is your I24. All I centers I have calculated. Location kahan hai? I hope everybody is clear. Tell me. Tell me in the chats if you are comfortable or not. Sir, all I centers I have find out. I24, I have also find out this. So all I centers I have find out. Now, how to solve our problem? Sir, question mein they might have given that length 2 ka at this instant angular velocity is something omega. It is rotating with omega to angular speed. Tell me angular velocity of length 3 or tell me angular velocity of link 4. They can ask this question. Any link ka velocity they have given, any other link ka velocity they are going to ask. How do I solve for this? For this, there is a theorem which is called as angular velocity theorem. Careful. What is the angular velocity theorem? Angular velocity theorem. Careful beta. Suppose exam mein they have given link 2 ka angular velocity and they are asking ki directly tell me what is the link 4 ka velocity. Link 2 के बारे में information they have given, they are asking link 4 का velocity how much, or link 3 का velocity, or any other link का velocity. So how we are going to solve this? First of all, for solving this question, you must know first that I center from where link 2 का absolute motion omega 2 can be seen. So I12 I must know. You must also find out what is the location of that eye center from where link 4 ka absolute motion is seen. I14 you must know, and then you must have a common eye center of body 2 and body 4, which is I24. So which eye centers I must find out? I12, I14 and I24. These are the 3 eye centers which I must find out, and then I can write omega 2 I12 से this I24 का distance will be equal to omega 4 I14 से I24 का distance. This is the method of writing angular velocity theorem. This is the way you write angular velocity theorem. What is the use of this? Just find out what is the distance of I12 and 24. Okay, these are the 2 eye centers. What is the distance? Just measure it from the diagram. 14 से 24, what is the distance? Just measure it. Omega 2 is given to you. You can directly tell me what is the value of omega 4. Like in this case, if they have given link 2 का velocity, link 2 is rotating clockwise. कैसे लिख रहे हैं भाई? सर, omega 2 I12 से I24, omega 4 I14 से this is I24, like this. So what is the distance I12 से 24? What are the eye centers first of all? Where we have to focus? Sir, I have to focus on I12. This is my I12. This is my I12. I14 is here. And where is I24? Sir, I24 is this side. These are the eye centers which I must know. Measure the distances. Measure the distance of I12 से 24. 12 से 24. What is the distance? You can measure this. 14 से 24. Sir, 14 ये है. 14 से 24. This is the distance. Just measure these distances. Put the values. Something centimeters. Omega 2 का value you have. Omega 4 you can calculate very easily. So you will get something omega 4. Something radian per second. बताइए. How I am solving questions? Sir, what if in the same question they are not asking omega 4, they are asking omega 3? How can I solve this? Omega 3 के लिए solve करना है. Solve करिए. Sir, link 2 का velocity they have given. They are asking about link 3 का velocity. How I am writing angular velocity theorem? What are the important eye centers? One eye center from where link 2 का absolute motion is seen, I12. One eye center from where link 3 का absolute motion is seen, I13. And then 2, 3, common eye center, I23. How do I write the equation? Omega 2, distance between omega 2 multiplied by 1, 2 से 2, 3 का distance, I12, 2, 3, equal to omega 3 से 1, 3, 2, 3 distance between 1, 3 and 2, 3. That's it. For this case, what are the important eye centers? Let me mark those, sir. 1, 2, 1, 3 and 2, 3. Where is 1, 2? Sir, 1, 2 is this. Where is 1, 3? Sir, 1, 3 is this. Where is 2, 3? 2, 3 is this. Getting my point? Just measure the distances. What distances? Sir, from 1 to 2, 3 is this. 1, 2, 2, 3 distance is this. 1, 3, 2, 3. From 1, 3, 2, 3 distance is this. Measure these distances. Put the values. Omega 2 is given. You can calculate what is the value of omega 3. From here, you can easily find out what is the value of omega 3. Something radian per second. How do I find the direction, sir? Sir, omega 2 is clockwise. As seen from I12, this is the I12. I12 pe if I am sitting here and looking at this length 2, how it is rotating? It is rotating in the clockwise direction. Omega 2. What about omega 3? Sir, magnitude you have find out. What will be direction? Will it be clockwise or anti-clockwise? How do I identify this? Just sit down at the common eye center. Sir, ये common eye center है. And look, where is I13? Sir, I13 is this side. Where is I12? Sir, I12 is this side. opposite direction में, they are in line. All these three isocenters are in line. So opposite sides में we are having 1 3 and 1 2. So that means directions will also be opposite. If your omega 2 is in clockwise sense, so this must be in anti-clockwise sense, opposite direction में. How does it look? Sir, length 3, its angular velocity, pure absolute rotation, I will be seeing from I13. You are sitting here at I13, looking at your link. How is it rotating? Anti-clockwise direction में. So anti-clockwise का मतलब होता है it is rotating like this. Getting my point? This is the omega 3. This omega 3 you have calculated. Sir, this is my omega 3 which I just have calculated. Sir, if this length is rotating with omega 3 anti-clockwise direction में, what does it mean? It means that from I center, if you are talking about this point of the link, its velocity will be perpendicular direction में here. Or from this I center, if you are talking about this point, so it will be again perpendicular direction में, it will be in this direction. Are yes or no? Perpendicular direction में, perpendicular direction में. If you are talking about some midpoint, from here, this is the point we are talking about. So this point, some point on the link, its velocity will be again perpendicular direction में. This is again 90 degree. I hope this is clear to everyone. So how for any link I am solving the question? Sir, in the previous question, what is the direction of 4? I am not going to tell you. You have to tell me what is the direction of 4. How can I identify? Sir, I12, I14. Sit at the common eye center. This is my common eye center. Sit down at the common eye center and look, where is 12? Sir, 12 is this side. Where is 14? 14 is the same side में, sir. 14 is this side. Both eye centers are at the same side. Common eye center से 12, 14 are the same side. That means whatever is the direction of omega 2 is clockwise. So whatever you have find out omega 4, it will also be in the same direction clockwise. How I am writing clockwise, anti-clockwise? I hope this is also clear to everyone. So examination में they will be asking magnitude, direction, and we can very easily solve this. Mr. Roy, Sujoy Roy, I'm not getting your point. Sir, can I write I14 to I24? Please clear my doubt. What is the doubt? What is the doubt? I'm not getting it. Okay? Now, many people might have this thing in your head that, sir, it is easy to say here that measure the distances. Measure this, sir. ये तो dimension है. I can measure this. How can I measure this thing? Gate examination में, do I need to draw the diagrams up to the scale so that I can measure it? No. What I'm saying, measure it. You can either make correct diagram and measure, literally measure it, or you can have some, geometrical circus, thetas, angles, Pythagoras theorem, properties of triangle. From there also you can find out some dimensions which I'm saying here. Let me give you one example, beautiful example. Like exam mein, how they have asked question they have asked in 2019 for 2 marks. They have asked one beautiful question. क्या पूछा है? Take out your calculator because I need your help in the calculation वाला part. For 2 marks they have asked this question. Question में क्या रहा है? A 4-bar mechanism is shown in the figure. Link numbers are mentioned near the links. So what are the link numbers? This link is link number 2, link number 3, link number 4, and where is the link 1? Sir, link 1 is this fixed wala link. Okay. Length of different links they have mentioned O2, O4, O2, O4. This link ka dimension is same as O2A. So these are the same dimensions, and AB dimension, O4B dimension, they are the same, root 2 times L. So this dimension same, this dimension same. Deltoid linkage. They are saying magnitude of the angular speed of output link 4 is called as omega 4. Output link is moving with omega 4. Input link is moving with omega 2 speed. Okay, this is moving with omega 2 speed. And the configuration which they have shown here, input link is making 90-degree angle. Tell me what is the ratio of omega 4 and omega 2? What is the relation between omega 2 and omega 4? How can I solve this question? Let me just draw this diagram a little clear. कैसे draw कर रहा है? Sir, this is the O2, O4. Same dimension ये है. This is same dimension. Then we have this. Then we have another link. ठीक है? Pin joint. This is also pin joint. This one is fixed link. Okay, so I'm not writing the name, just link number 1, link number 2, link number 3, and this is my link number 4. This angle is 90-degree angle. Or if I make this diagram even more correct, what is the, if this is L, this is L, root 12, root 2 matlab hota hai 1.4. 1.4 is almost, this is L dimension, so 1.4 will be something like this. And something half of the double. And if this will be double, so root 12 will be somewhere here. Root 12 dimension will be something like this. Let me check if I have made the same dimensions, almost same dimensions. ठीक है, almost. One dimension is this, another dimension I must draw. क्या बात है? Proper, without scale, I have drawn this diagram utmost beautiful. This kind of situation we have. Link 3 and this is link number 4. Okay, this is the pin joint. Dimensions क्या है? Sir, I have this dimension as L. This is also L. This is root 2L. This is also root 2L. Clear? Link 2 and link 4. They are asking relation between omega 2 and omega 4. How do I identify? Sir, between link 2 and link 4, if I apply angular velocity theorem, how do I write? I can write this as omega 1, so omega 2, I12 say this I24 common eccentric का distance will be same as omega 4, I14 say I24 का distance. Is this clear? So what are the important eccentrics which I have to find out? I have to find out location of I12. Sir, where is I12? Let me draw. Sir, link 1, link 2, this is your I12. 2 and 3, this is I23. 3, 4, this is I34. Link 4, link 1, pin joint, so this is I14. So I12, I know. I14, I know. Where is I24? Kennedy's theorem. You can draw that circle and from there you can write. Chalo, let me write. Sir, I24 ko, can I write? It will be in line with 1412. 1214 के साथ it will be in line, and 23, 34, 24 will also be in line. I have directly written because in my mind I have drawn that circle. I can feel it. And you can try, you can draw that circle and from there you can write this relation. So where is I24? It is in line with 1214. Where is 1214? Sir, this is 12, this is 14. So on this line I am going to have my I24. You are saying it will also be on this line. Okay. So wherever both these lines are going to intersect, can I say that is going to be your I center? So they are intersecting somewhere here. This is the location of I24. In this diagram, location of I24 is there. Now, what you have to do, just measure the distance between 1, 2 and 2, 4. Where is 1 to 2, 4? Sir, 1, 2 say 2, 4 is this distance. I am calling this distance as x. Measure this distance. 1, 2 say 2, 4. Just measure it. Where is 1, 4, 2, 4? Sir, 1, 4 say 2, 4 is nothing but whatever is the x plus L distance. So just measure the x, then I can solve this question. How do I measure the x? One thing I can say, just measure it. Make the diagram and measure it. Other thing is using some geometrical properties, Pythagoras theorem, triangles ka property, you can solve this question. I have to measure this dimension. How do I think? Look at this triangle beta. In this triangle, right angle triangle, this is 90-degree angle. This dimension I have to find out. This dimension L already I know. If somehow you can find out this angle or this angle, just find out the angle, then I can very easily apply sin theta cos theta wala some logic. How do I now? My problem is to find out the angles. How do I find out the angle? This is 90-degree angle beta. If you connect like this, can I say this is L, this is L, 90-degree, this is L, this is L. So this angle is 45 degree, same angle. And what will be this dimension? This is root 2L. So this angle is 45 degree. This is also 45 degree. Now look at this triangle beta. All the dimensions are same, root 2L, root 2L, root L. It means all angles are going to be 60, 60, 60 degree. This is 60. This is also 60 degree. This is also 60 degree. Yes. Now this total is 180 degree. 60, 45 plus. How much angle this will be? Sir, it can be 105, 75 degree. This is 75 degree beta. So you have find out this angle as 75 degree. This is 75 degree. This is my 90-degree angle. You can also find out this angle. So in this triangle, I have got what are the angles. Can you write what is the value of x? X को क्या लिख सकते हैं? Sir, I can write tan of the 75-degree angle will be, for this right angle triangle, tan is perpendicular upon base. X upon what is this value? L. So what is the value of x? L tan 75. बताइए. L tan 75. What this is the value of x. Now, how do I solve? Sir, 1 2 say 2 4. This distance is x. 1 4 say 2 4. What is this distance? 1 4 say 2 4. X plus L. X plus L. Solve it. हो गया, simple. Solve the question. What are they asking? Omega 4 by omega 2 or yes, omega 4 by omega 2. So omega 4 by omega 2. Omega 4 by omega 2. It will be x upon x plus L. What is the value of x? Beta x can be written as L tan 75 degree divided by L tan 75 degree plus L. L, take it common, it will get cancelled. Solve it and tell me what is the answer. Tan 75 divided by tan 75 plus 1. This is the value of omega 4 by omega 2. Anyone with answer? What is the value? You can solve this question, beta. What is the approach for these kind of questions? I hope that's clear to everyone. Yes. It is not tough. Velocities ka questions are not going to be tough. In fact, entire theory of machine is all about geometries, diagrams, geometries, properties of triangles, everything you must know. ठीक है ना? चलो. Sometimes they can also ask question like this. If we are having a question was asked in 2011 for 1 mark, and actually this question is asked multiple times. Many times they have asked this similar question. Question में क्या है? Question में they are saying 4 bar linkage is shown in the figure. Angular velocity of link AB, this link AB ka angular velocity is 1 radian per second. It is moving in anti-clockwise direction. Length of this CD link is 1.5 times of the length of this AB link. The configuration which is shown here, this is 90 degree, this is also 90 degree, यानी कि input output link they are parallel. Horizontal के साथ they are making both 90 degree angles. Tell me what is the angular velocity of this output वाला link. Same question. Do you want to try? Yes. Do you want to try this question, beta? Let me draw the diagram a little clear. Question में you are having this fixed link, input link, coupler, and we are having this output link. ठीक है ना? It is moving with 1 radian per second anti-clockwise direction में. We are having this pin joint, this pin joint, pin joint, this is pin joint. Situation is this, है ना? Let me give it some name. This is my link number 1, link number 2, link number 3, and this is my link number 4. This is 90 degree, this is also 90 degree. This situation they have given. Let me call this as omega 2. Omega 2 ka value they have given. They are asking, tell me what is the omega 4. How many of you can understand how we have to solve this? Apply angular velocity theorem. Link 2 ka velocity they have given. Link 4 ka velocity they are simply asking. What I centers I must know. One I center I12. From where link 2 ka absolute motion omega 2 is seen. Omega 4 I must know. Sorry, I14 I must know. From here omega 4 will be seen, and one common I center I24 I must know. Equation कैसे लिखेंगे? You will write equation omega 2 I12 से I24 equal to omega 4 I14 से I24. बताइए. That's how we are going to write the equation. Now what you have to do, you just have to locate I12, I14 and I24. है ना? Let me help you. Sir, link 1 and 2. So this is I12, I14, I34, 23. This is your I23. Where is the 24? Sir, again 24 will be 1 2 1 4 के साथ it will be in line. 2 3 3 4 के साथ it will be in line. And wherever these two lines are intersecting, can I say location of I24 will be there only? I have got this line A at this location. This is your I24 का location. Simple. Similar question, just we have solved it. Now you are left with geometry only. Bhaiya, this is the geometrical question in front of you. What do you have to do? Just find out from I12 this what is the distance I24, and from I14 what is the distance. You can either simply find out the distances, or if you use a little common sense, can I say, sir, if you look closely, at this triangle, this one, and look at this big triangle. Both these triangles, can you say that these are both similar triangles? Why? Because smaller triangle mein this angle is 90, bigger triangle mein this angle is 90. Okay. Smaller triangle ka this angle and bigger triangle ka this angle, that is common angle, है ना? तो obvious सी बात है, the third angle will also be same. So two triangles, smaller angle, bigger angle, they are the similar triangles. If they are similar triangles, so ratio of the sides must be same. मतलब ratio of the sides must be same. मतलब if you are talking about smaller triangle का I12 12 से 24 this distance divided by bigger triangle का 14 से 24 distance I14 से I24 distance, it will be same as smaller triangle का perpendicular, bigger triangle का perpendicular. Smaller triangle का perpendicular is distance L, bigger triangle का this perpendicular it is 1.5 times of L. Question it was given. Dimensions are like this. So smaller triangle ka this is L divided by 1.5 L. Can I simply say this? So ratio of I12 से 24 and 1424, यानी कि this 1224 and this 1424, this ratio, do I know this ratio? Yes. कैसे लिख रहे हैं सर? Just copy this ratio here, this ratio, and what is this ratio beta? This ratio I know it is how much? L by 1, L divided by 1.5 L. Solve करिए. Omega 2 का value is given as 1 radian per second into L divided by 1.5 L. This is the value of omega 4. Simple. Examination में questions will be asked like this. 1 mark question, 2 mark questions. Clear है? Solve करिए. L gets cancelled. This is 1.5, 3 by 2. So answer is 2 by 3. So omega 4 I am getting as 2 by 3 radian per second. If I ask, although direction they have not asked, but can you tell me what is the direction beta? If link 2 is rotating anti-clockwise, what will be omega 4? Clockwise or anti-clockwise? How do I say? Sir, sit down at I24. Check karo. Where is I12? Sir, I12 is this side. Where is I14? I14 is also this side. Same side mein. So this is anti-clockwise. This will also be anti-clockwise. This will be your omega 4. बताइए. Anyone having any kind of problem here? ठीक है? Great. बहुत बढ़िया. I am glad that if for the very first time somebody is studying this, and if you are able to grasp this concept, nothing is left. ठीक है? One more question we will do. One more question. As I said, most of the question, 90%, 95% questions in the examination you will solve with the help of I-center method. GATE 2022 mein this question for 2 marks they have asked. Can you solve this question? In the configuration of a planar 4-bar mechanism at certain instant, Read out this question and try to solve this better. In the configuration of planar 4-bar mechanism at a certain instant as shown in the figure, angular velocity of 2 centimeter long link. This is the 2 centimeter long link, 5 centimeter, 4 centimeter, and the fixed link ka dimension, yani from this fixed point to other fixed point distance is given as 10 centimeter. Okay? The configuration which they are talking about is 2 centimeter ka link has become horizontal. They are talking about this. At this instant, link 2 ka angular velocity is 5 radian per second. Hello? Hello? Hello?